Testing, testing. 1, 2, 3. Testing, testing. In frame. There we go. Cool. Hello. Welcome. This is yet another edition of Some Dude in the TV telling you how programming works. I will be your host this evening, and today we are going to be talking about the lovely class of classes. There we go. So, yeah, so I suppose we could also talk about test 2. If they can stream for 720p from the ISS, there's no reason why I, yours truly, could not be in 4K. Well, the the problem is that on the International Space Station, they probably have much more expensive equipment than I do. So there you go. Welcome, everybody. So we could, I suppose, in theory, talk about Test 2, which is coming up this weekend. Or we could save that talk for Wednesday's lecture. If you guys start asking me questions about Test 2, I'll answer them. Otherwise, I'll just continue with the show. So, yes. And yes, I did shave. You know, if you only shave once every 2 weeks instead of shaving every day, your razor blades last literally 14 times as long, which means that you don't need to replace them but once a year, or there's about. So there you go. But I think it's actually been longer than 2 weeks. Yeah, it was starting to bother me. But anyway, I have a face, and so does the face of the topic that we're talking about. Segue! Ha! So, with respect to this class's unit, we're going to motivate things, and then we're going to get into the nitty-gritty. So, what's the best way to practice for the upcoming test? Well, I'm so glad you asked. There is, in fact, if you take a look in Week 5, Test 2, there is a practice test. Haha. So, this is from a previous semester, so the TA names are wrong, but that's okay. Generally speaking, these are good questions to practice on. I know they're not in Jupyter format, which, you know, what are you going to do? But a lot of these are good questions which you may practice. It seems they focus mostly on the recursion and data type stuff, which is good. So, or the the binary representation stuff. This is a good resource. Practice test. It says 1, but it means 2. It says midterm 2 up here. Anyway, question: how many questions are on the test? 5. I think it'll probably end up finishing off at 5. The test is pretty much together. I just have to do a few more refinements. What lectures will Test 2 cover? Test 2 will cover all of the lectures that have been in the preceding 2 weeks. So, since we had that holiday, the holiday Monday 2 weeks ago, there's actually only 3 lectures that Test 2 applies to. We've got the testings and exceptions material. We've got the data types and data representations material. And we've got the functions and recursion material. Those are the 3 things that are going to be tested. There you go. Yep. So, hopefully that answers that question. I'm pretty sure that it does. The other thing that you could try, I know that Coding Bat has a Coding Bat. So Coding Bat is a great resource. It's got the Python side, which is cool, but it's also got a Java side, and it would be, I think, worth your time to, for example, take a look at the recursion functions, or the recursion practice questions here. Not implement them in Java, obviously, but you can try your hand at implementing them in Python. Of course, you won't have the interactive interface available to you. However, I believe it does tell you what the test questions are, so you are there should be some test cases available to you. So there you go. How difficult is the test when compared to Assignment 5? Because Assignment 5 feels pretty brutal right now. Assignment 5. What's the material on Assignment 5 again? Should be... Oh, yeah, the lead... Oh, is that on that one? No, I think that was on the early one. Move, Internet. I command you. So, not gonna lie, the difficulty of Test 2 is gonna be a bit higher. Oh, yeah, okay. So, Assignment 5 requires the material from this week, you know? Like, the intention is that the lecture material in the week that the assignment is due is applicable to that assignment. So the idea is like you learn it in lecture and then you do it, you know, immediately to reinforce. Can this work? Okay, fine. Ah, yes. So this is all a bunch of classes and file I/O stuff, so it would seem. So I hope that that material is going to be a bit more clear to you after after we've had our lectures today. So I guess we can get into it. So the questions on Test 2 are harder than the questions on Test 1. This has to do with the sort of inherent difficulty of the course increasing substantially since the first few lectures that we had. It's also, I noticed that the average on the first test was very, very high, which perhaps means that I'm not quite challenging you guys enough. And I know that that's never a thing that students like to hear, but the questions on Test 2 will be more challenging than the questions on Test 1. So, you know, take that as you will. So, in accordance with that, I will now provide a couple of hints. Hint number 1, I highly recommend knowing how recursion works. That's not much of a hint. Knowing how memoization works would also be beneficial. You should be writing this down. And the other thing that would be useful to know how it works is all of the little ways in which floating point can go wrong. So some alternative way of dealing with floating point numbers that's safe in all contexts. If you know something like that, that will serve you well as well on the test. So, anyway, unless there are any more questions, a Sith doesn't back down from a challenge master. Ah, good. Well, I hope that you shall find Test 2 to be sufficiently challenging. I've actually been having a lot of fun writing it. I think some of the questions are quite neat. Not quite as, like, gamey, interactive-y as the Conway question, but, you know, we'll see. Anyway, let's talk classes. So, before we talk about classes, we should have some sort of rough idea what classes are. What is the business we are taking a class? Is that classes? So, within the broad scope of programming languages, you have various paradigms. And, you know, we've already touched on this back in the first lecture. You have imperative languages, which are instructional. You have functional languages, which are based on lambda calculus. And you have object-oriented languages. Now, most of the quote-unquote imperative languages that you will be dealing with should rightly be considered object-oriented languages. And maybe if you guys are down, I might show you some particular details of a particular personal project that I'm working on at the moment, a commercial product that I'd like to release at some point in the future. And I'll show you around the development environment, and I'll relate that development environment back to the idea of object-oriented, because object-oriented really is it's fundamental to the manner in which software is written. You can't really call yourself a software professional if you haven't worked in object-oriented languages. Object-oriented languages include things such as C++ and Java and Python. Although Python is considered a multi-paradigm language, C++ as well has acquired a certain amount of functional elements over the years, but JavaScript, I'm pretty sure, is also considered object-oriented. C# certainly is considered object-oriented. I'm pretty sure Visual Basic is as well. So what is this? What is object-oriented? Why are we talking about objects? So object-oriented programming refers to what the first class citizen of the language is. And that's sort of a term that you sometimes hear applied to programming languages. In a functional language, the first class citizen is the function. So everything is a function in one way or another. In object-oriented programming, the object is the first class citizen. So lots and lots of things are objects. But how do objects relate to classes? Well, an object is an instantiation or a concrete instance of a class. A class is a template from which an object is created. So we are going to learn over the course of this lecture how to create objects and classes. So let's get on with it already. So let's motivate things, although the motivation is somewhat different from, Anyway, so exceptions. We've been dealing with exceptions lately. There's been quite a lot of talk about exceptions. You may have noticed that the exceptions that you raise are limited to the sort of pre-baked we have a name error, which is not a my custom error. My custom error is not defined, so this is a thing that does not exist. Is the chat or the stream died? Oh, okay. Really? Because it's still coming through on mine. Ooh. Okay. Gross. Okay. Okay. All right. what was I talking about? I was talking about errors, right? So going back to the slide, I don't think we missed too much. When you raise an exception in Python, you're raising these pre-baked errors, right? The error names are built into Python. So if you want to raise a value error, then that's fine. And you all, I hope, so if you raise a value error, you guys didn't really miss much. Yeah. Value error you can raise. However, if you want to raise my custom error, it tells you that the name is not defined. My custom error does not exist. So, why is that? Hypothetically, it would be a useful thing to be able to define your own error types. So, and here are, of course, all of our error types that we discussed on the at the beginning of the at the end of the last lecture. So, if you wish to raise a custom exception, there are a couple of ways of going about it. Number one, you can actually use exception my own error message. This is cool. So if you want to exception my error, you can see that it creates an exception and gives it the title my error. So there you go. This is a way that you can put custom information to the screen. However, if you wanted to catch that using our error recognition, or sorry, it's not catch, that's in C#. So if you wanted to catch my error, for example, print this shouldn't work. There you go. During handling of the above exception, another exception occurred. My error is not defined. So the problem is that this doesn't actually create an instance of an error object. So the errors that we've been dealing with are, in fact, objects. When you use the name exception, exception is the name of the class that generates exceptions. All exceptions are instances of this exception class. So, in order to create a new custom error type that we could even do except matching on, we need to do something other than what we've been doing so far. So, this is what you do. You actually can create a class. Oop, geez. My error. Class, my error. Inherits exception. So, this is a new thing. This is brand new for us. In order to create a new class, which is a template for objects, use the keyword class, then give the name of the new class that you want to make. In this case, we will make it my error. In order for my error to behave like an error, we have this fantastic thing called inheritance. What inheritance means, what it does is it allows a class to pick up the attributes of another class, sort of absorb all of them into itself, but it's called something else. You can absorb all of these things, and you can put it on this would have been helpful for assignment 4. Assignment 4 was about errors, I hope, and not classes. Yes. So anyway, if you have it, exception is the name of the class that we would like to inherit from here. So in this particular case, we don't actually want anything other than the basic description of what an exception is. We just need what exception is. So we put in a pass. just to make it syntactically correct. Pass, of course, the keyword pass, you may have seen it in some of the assignments. It means do nothing. It means, it's like in Uno, you pass. I don't know, can you pass in Uno? Possibly. It has literally been 2 decades since I've played Uno. So, anyway, if we do this and raise a myError exception, you can see that that Python is actually, it's correctly accepting myError as a new and valid error type. Ah, you draw in Uno. Okay, well, whatever game you pass in. Oh, euchre. It's euchre that you pass in. So, this is cool. This is giving us control over the subsystems that we're using in a way that we haven't had it before. So we can create new custom types of exceptions. Next, motivation number 2, custom data types. So this diagram that you see before you is a family tree-esque description of people from a well-known series of fantasy novels. We are going to create a class that allows us to more easily describe people and their relationships. So, using ordinary data structures, it's definitely possible to keep records of all of these people and all of whatever information you consider pertinent. In this particular case, we consider their name, their children, and their spouse to be the pertinent fields of information. So we have a number of names and a number of arrangements of the data. You can see that children is a list. So obviously a person can have more than one children. However, a person may have only none or some spouse. And notice that the spouse here refers to the it refers to the data structure that was instantiated on the previous line, right? And then you can assign things back and forth. So can we refer to Python as parcel? Thank you, Nick. That was a good joke. Good joke. +1 joke. Yes, I suppose you can. But yes, so this is what's known as programming with a convention. Conventions are great. Conventions make everything work together more nicely. When you are creating large numbers of pieces of data, it's always a good thing to have some idea of how that data should be in a sort of standardized format, right? There's a problem, though, with doing this way. Notice here that Harry P, our entry here, has name and children assigned, but it doesn't actually have the spouse assigned. The spouse is assigned later here. Imagine if that particular element, or if this particular line was excluded. The problem that you'd run into is that you would have one of your data records which doesn't have all of the data fields that you're looking for. So if you wrote some algorithm that was based on the assumption that everything has a spouse field, but this one guy, he just won't say one way or the other whether he has a spouse, that would cause a key error, I believe. And a key error would be enough to cause the termination of the execution of your program. So it's generally speaking undesirable. So the question becomes, is there a better way? And the answer is, why, yes, of course. let's create one using classes. So we shall create a new class. It shall be called person. It shall inherit from object. In Python, the most general thing that a thing can inherit from is an object. So if you have something that inherits from nothing else, it should inherit from object. This provides it a number of very useful things like an initialization and anyway, it's useful to inherit from object. So within a class, you have, generally speaking, two main things. You have attributes and you have methods. Attributes are pieces of data that reside inside of the class. You can think of a class in some sense as a bundling of variables. If you are a C programmer, you would think of it as a struct. Or a structure. So there you go. In Python, the way that we tell this class what fields it has, what attributes it has. Field and attribute are synonyms in Python. Is we create a definition method. This init, it has to be preceded by 2 underscores, and it has to be followed by 2 underscores, and it has to be called init. This is the initializer. And the initializer, any code that you want the class to run upon initialization, i.e. when it's created, that code would go inside of the initialization method, the thing that we currently have the cursor in. And in this corner, I think I got that right, the other thing that you do is you create any of the pieces, any of the fields that you want accessible during for the other methods inside the class. So, pardon me, sorry. So in this particular case, we've got rip, 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 rip. There you go. Name, children, and spouse. Notice that these are strings, right? So like variable names would be a thing that you could do too. So name is equal to none. Children is equal to an empty list. And spouse is equal to none. However, it's not quite so easy. We'll get into this. Oh, yes. British coders be like, nice class, innit? Yeah, nice joke. Good jokes. If this was D&D, I'd be giving out inspiration points. Anyway, it's not sufficient to just put the names in. This will make it local to the method, but not local to the class. In order to make it local to the class, you have to bump it up 1 level. And in order to do that, you do self dot. So everything in a class is accessed via dot syntax. So self dot main means the particular instance of the class that is currently executing its initialization method. That it makes the variable name refer to the instantiated object or the class. It refers to it at the class level rather than locally at the method level. So that's how you create fields inside of a class. Yes. So here's yet another slide, that tells you a bunch of stuff that I've already told you. We had a convention. If we make a mistake with the convention, oh, that's the other thing. If you misspell one of the tags, then that's also an issue. What if I forgot a key in one person's dictionary? Functions that expect certain keys to be present might fail. You can't use type or is instance to distinguish between dictionaries that represent people and dictionaries for other purposes. Yeah. Yes. Oh my goodness. So there's a comic that I really like that is this person this person says to this other person, why are you playing video games? Don't you need to study for that test that you have coming up? And the other person's like, oh, it's fine. I'll just borrow my brother's +5 cloak of wisdom. And then it cuts to this person in the test, puts on the cloak of wisdom, eyes go wide, and he's like, I should have studied. I like that comic. So anyway, the ideal, so the thing about a class is that it fixes all of these problems. We essentially are not only assigning specific tags inside of a dictionary, we're not just creating a convention, we are also creating a policy for that data to be interacted with. That's kind of like that's the big brain way of thinking about classes, is you're not only bundling data together, you're also determining how that data is to be accessed and used. That is what the purpose of methods are. The initialization method, it tells you, well, first of all, it tells you what fields are to be interacted with, but it also tells you how those fields are to be initialized, right? And this is something that we haven't really had to deal with in Python just yet, because Python's like, oh, you don't have to initialize anything, but you do. Regardless of whether you require explicit type declaration. So, if you want the user to have to specify what the name of a person is when they create an instance of the class, you create an argument inside of this list of in this list of parameters. So you can add as many parameters as you want to the initialization function. It might have been the fact that we're using def here. That might be a bit of a giveaway, but methods inside of classes are functionally equivalent to functions. They are declared in the same manner. They are local to the classes that they're declared in, and you can have as many parameters on them as you want. So, another useful method that we might have here, and I'm just kind of doing stuff here, we might want a add child. So self takes self and a child, and self dot children dot append child. Oops, syntax error. Forgot me my colon. So, if we then declare a person, we need to provide, let's say Harry is a person with the name Harry P. If we take a look at harry.name, we get Harry P. That's how you access stuff inside these things. So, if we want to add if we want to add a child using this method, we have to use the same dot syntax. Harry.addChild. I don't know what it doesn't matter. Bartholomew. There we go. Then Harry dot children, that gives you that list, right? So essentially, methods are correctly thought of as data access policies, right? When they don't just have to be data access policies. They can contain algorithms themselves, right? They can do very complicated things. They can do anything a function can do. However, if it's not operating on the fields that have been declared in the class, then it's not really a method. It shouldn't really be a method for that class. It should be a function declared outside of that class. But oh my goodness. Yes. Oh my goodness. Don't even get me started. Don't even get me started on how terrible the Fantastic Beasts movie was, the most recent one. It's no bloody wonder they haven't released another one. They probably haven't in shame. It was terrible. Like, it's supposed to be it's called Fantastic Beasts, and there was like no new beasts. It was all old beasts. It was terrible. Anyway, so this is how you can create classes to do this kind of stuff. And you can see that this is the code that I have just produced in Jupyter. Basically, we use the class keyword when defining a new class. We say that my class extends what it's building on. So this object, the nomenclature is that person extends object in the same way that my error extends exception. So that's some important nomenclature. And we can always extend the built-in starting point object. As I said, if nothing else, I'm going to have to talk to Soros about these quotation marks. You can always extend object, so if you're inheriting from nothing else, you should be inheriting from object. Let's just see if this works without object. I'm curious. Yeah, it still works without object. Object has useful stuff in it, though. Useful stuff. So, now that we have a template, next we have to define a template for our custom data type. Yes. So, now that we know what the data is, we can tell ourselves how it's to be initialized and what operations you can perform on it. So this idea of initialization is kind of a new one, but you can think of it like a tree, right? A tree starts off as a seed, but the initial conditions for that seed are the DNA of the plant, right? Everything is going to grow from the DNA. So you can think of you can kind of think of the initialization, the manner in which it's initialized, as the DNA of an organism. It dictates how it grows, but it doesn't dictate the environment in which it operates. What other things can you inherit from? Literally anything. So we're going to get to some examples of it later on. I don't want to step too much on my own toes here, because we're going to have several slides about chains of inheritance and multiple inheritance and all kinds of things. So let me get there. To the question, could you explain why you use underscore underscore init underscore underscore? Yes, I can. Because nothing else would work. If I remove the underscores, I get a problem. Type error. Person takes no arguments. So without this redefinition of the initializer, it defaults to the regular initialization of the initializer, which determines that it is initialized with nothing, essentially. Like, even if I take away this argument that is asked for, I still get a problem, attribute error, because person has no object attribute, no attribute children. The whole thing is that the adding of the underscores here, and I know it's a weird way to name it, but this is actually the convention for classes. This dictates, you'll sometimes hear the term magic method used. What it really is it's a method that is provided by the Python prelude, which you are providing a new definition for. You're overwriting the existing definition for init in order to mean what you want it to mean for the class that you're defining. But you have to have that name exactly, because otherwise it won't link the stuff going on inside of it to this, which is correct class instantiation syntax. And there's some other cool things that you can do as well. So we're going to get to this kind of stuff, but here's a sneak preview. If you use EQ with two underscores on either side, you can actually overload the double equal sign, the equality comparison. So if self return self dot name is equal to other dot name, and self dot children equals other dot children, and we won't worry about the spouse. So if we have, for example, person A Betty, and person B is a person named Betty, and they have no children, which means because we have not called the add children method, A equals B is true. Without this definition, you don't just get that for free, right? It's interesting, actually. Rather than this is kind of a technical point, but rather than evaluating whether or not two objects of the same class have the same fields in order to determine equality, the default for class comparison is actually, it checks for aliasing. It checks to see if the memory pointers are the same. So this should work. Yeah, true. So it's comparing memory pointers by default. Now, it's entirely probable that you don't want it to compare memory pointers by default. You want it to, perform some sort of comparison on the actual fields existing inside of the class. In order to do that, you have to define what equality means for this class. And the way that you do that is by overloading Python's default method, underscore underscore EQ underscore underscore, in order to tell it what equality means to you. So hopefully that answers your question. There is a literal butt ton of methods of this nature, which looking them up, you can look them up in the Python documentation. I leave that as an exercise to the viewer, because I'd like to get through the motivations before the first break. So, init, two underscores on either side, is a special function called the initializer. It is called whenever we try to make a new instance of this class. So when you do this, init is called by default. You notice that one difference between my version and their version, this version in the slide, is that no no additional argument is provided. We'll get on. I'll explain the self thing a little bit later on as well. We have some good examples coming up for that. Inside the initializer, we can define instance variables that are associated with each instance of the class. Instance variables are sometimes called members, or properties, or attributes. You will also hear me refer to them as fields. Field is kind of a somewhat antiquated nomenclature, but that's fine. You know, how many default class methods do we need to know for this course? You don't need to know any of them off by heart. You just need to be able to look them up in the Python documentation. How many do you need to know? Well, you need to know init for sure. EQ is a useful one. str for the string, that's one that you should probably know. I don't know, if you know EQ, then you could know like a lot of the comparators. They're just, you can look up what the names are for each of the comparators. Add, multiply, subtract, divide. Just know how to overload some of these things. I believe there's a table coming up in this set of slides with all of them, but I don't want to jump too far ahead of where I am in the slides right now. So there you go. Different instances of the same class will have independent instance variables. Yes, that's a good point. So in this case, where we have two people named Betty, right? A.name. Why don't I just do this? Here. Octothorpe. There we go. So A.name is Betty. B.name is Betty. But it's important to know that they are different, right? Each instance is its own instance. They don't interact with each other. Modifying one will not modify another, unless you're dealing with aliasing and doing things like A equals C that I just deleted. If you do that kind of thing, then all bets are off. But generally speaking, the data that's inside of classes does not interact with itself. They don't interact with each other. So there you go. So this particular instance, we add another method. The method that I showed you was more adding information to an object, but it's also very important to have methods whose primary purpose is to get data out of the object. And the data that you get out of the object does not just have to be the fields of the object. That wouldn't be necessarily the most useful thing. So def is married is a test of marriage. Self. If, well, actually, you don't even have to use an if statement. Return self.spouse equals or doesn't equal none. There you go. So a dot is married should be false. So that's okay. So that's another important thing about methods. Because they're essentially the same thing as functions, you can't forget the braces at the end, much as your professor does in class. So there you go. Is married. Ta 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 ta. So another term for method is member function. So there you go. Cool. So that concludes our section on the motivations behind object-oriented programming. We shall resume in about 8 minutes. Talk to you guys soon. Hello and welcome back. I brought a little kitten, and she's so cute. Are you still purring? I think you are. Give it. Yeah. Anyway, little Rimby, say hello to the internet. Oh, so offended. Anyway, her tail continues to get poofier. So, question, why do we use none instead of an empty string? That's a good question. We're using none here instead of just like blank. It's like you want to be able to distinguish between something that like might be a legitimate I have intentionally put nothing here, as opposed to a case where nothing has yet been put there, right? So using none instead of using an empty string for each of these fields, it allows us to distinguish between basically it allows an empty string to be a legitimate thing that a person could enter, right? But yeah, rumble. Anywho, let's keep moving. Let's talk about classes and objects. So everything in Python is an object. Literally everything. So if you notice with Python, if you call type on even something like a number, you get, oh, come on, man. I guess you have to do it in the interpreter. PowerShell! There we go. Python. Ta-da! Type. 45. See? It's a class. It's of class integer. Even something like type of type for is class type, right? If we define a function, that is also that's also a type of class. Everything is a class. That's why classes or everything's an object. That's why objects are the first class, so to speak. The first class citizens. So the class definition defines attributes, properties, variables, members, and methods that are common among all instances of that class. Attributes of a class or an object are referred to or referenced using the dot notation. As we saw previously, in order to access the name field, you do b.name. It works for assignment and it works for reading and writing. And if you wish to call a method, you must do it in the same manner. However, there's actually a couple of ways that you can do it. The other way you can do it is you can refer to the object or the class name, person.married, person.isn't married, and then apply it to an instance of person. And that gives you the same result. So where's paint? I need paint for a second. So if we have the thing tool, yes, size, can I do that? Kind of right. Oh, there's the there we go. So if we have two different function calls, right? Come on. If we have person, if we have Harry dot is married, and we have person dot is married Harry, these are two ways of referring to the same thing. So you may have noticed in the definition that we have this self parameter, right? There's a self that goes brushes right in here in the original definition, right there. So the way that things work is there are two ways of providing that information. Number one is to call the method directly from an instance of that class. Since the object knows that it's an instance of person, it knows where to look for the function or the method. And because you have specified what the instance that self is supposed to be, by using dot syntax, you don't have to provide it. You do not have to provide it here. However, it is also possible to refer to the method name using the class name specifically. So person dot is married. Because we have decided not to supply the instance, the object that we're operating on here, we then have to specify it as the first argument to the method. However, this is syntactically the same thing, syntactically equivalent. And you'll see in a few slides, there's like this might seem like, oh, why is he teaching this? Two ways to do the same thing. What the heck, man? One way is obviously shorter and therefore better. The problem is, Albert says, I thought Python only liked to do things in one way. This is blasphemy! Yes, it is blasphemy. But here's the thing, right? There's your ideals, and then there's reality. And sometimes, in order to get your ideals to interface with reality, you have to kind of meet reality in the middle. And I think the Python people have had to meet reality in the middle a little bit. At any rate, this is useful syntax in different instances, specifically in instances where perhaps the name of, well, I suppose you could just use self. There are some interesting cases in inheritance where this is actually the only way. This bottom one is the only way to do something. So that'll be interesting. But yeah. Anyway, next point. So here's another example. This is a class that defines points, as in points in Cartesian space. So we've got an x, we've got a y, we've got a move and scale and distance methods. So this is cool. I'm just gonna, let's just create that, shall we? Or, I don't know, copy it and paste it. That'll do too. Fix the indentation. What? The door's open. You just have to open it. Pardon me, the cat wants out of the room. So, if, for example, we wish to define a point 3, 5, and we want we'll call that Q, and we want to determine another point P is 722, then Q dot distance P is that. The other way of writing that is point dot distance QP, or PQ. There you go. This makes it a little more explicit that it's a, what do you call, binary function. Sorry. Yeah, sorry, my mic was farther away from my face. Silly microphones! So anyway, this is a way that you use it. This is that alternative way of writing it again. You'll notice that this makes it kind of explicit that what you're doing here is a binary function, whereas in the previous version it was just kind of implicit. So there you go, etc., etc. So methods are called using dot notation. The first parameter, named self by convention, is bound to the object. So it doesn't actually need to be named self. However, it is bound to the object. Calling it self makes a lot of sense, so I always recommend calling it self. P.move11 is equal to point.move p11. The init method is implicitly called when an object is created. Its parameters have to be supplied at object creation. So if you don't call a initialization function with all of the parameters it requires, as is the case with any other function, it will complain at you that you don't have enough. However, you can also have default arguments in the same way that you can for functions. So that's cool. So, printing objects. You'll notice, this is kind of cool, that if you print out, it might not work here, it might work better somewhere else, but if you wish to print, for example, the point P, what you get is main.pointObject at this thing. So that number, which you'll notice is expressed in hexadecimal, that's the notation for a number that's in hexadecimal. This means hexadecimal. This is the number that's in hexadecimal. This is a memory address. This points to a piece of memory inside of my random access memory inside of my computer laptop, which is cool. However, maybe not useful. Maybe rather than printing the memory address of the point, you actually want to display the position of the point, for example. You can use another magic method, def, which I've alluded to already, called str. You guys remember the str function, which you can use to convert things to strings. This is overloading that function, which is one of Python's default whatchamacallums. It's a prelude function. Yeah. So return, and we'll just make it a little pretty. That plus the string interpretation of x, self.x, plus comma space plus string interpretation of self.y. Those both work, by the way, because self.x and self.y are, after all, not like they're objects for which string is defined, because they will be numbers. So there you go. Now, if we run this, we get a very nicely formatted tuple. There you go. So str with double underscores. That allows you to override str. So the thing is, right, sorry, maybe that's not completely explicit. When you print something, you're calling str, you're calling the string conversion function by default, and then it just kind of prints it to the screen. So that sort of overloads it, if that makes sense. So anyway, that's cool. That's a cool thing. By default, print outputs an internal representation, usually a memory address of the object. We can override this with the str method. This applies this to the person object, but or the person class, we applied it to the point class. So that you guys could get the point! Oh! Snap. By default, equality comparison compares an internal representation, usually the memory address of the object. This is something that I was just saying. You see, I have this habit of getting ahead of the slides. So, again, if you have P and Q here, is P equal to Q? No. What if their values were the same? Still no. If you have some third thing, which has the same memory address, that is true. That's because C is an alias of Q. This is a test for aliasing. So, if we wish for EQ to be defined, we must define it ourselves. It takes self and other. This is by convention for binary things, binary methods. So return self.x is equal to other.x, and self.y is equal to other.y. Then P does, in fact, equal Q, unless, of course, their values are not the same. So there you go, in summary. Yes. So double underscore EQ, double underscore, that's what you want to do. Cool. Classes can be used to create objects and to define new classes by inheritance. All the definitions of the base class, i.e. the parent class, are inherited as if they were copied and pasted. So, inheritance. You can it's kind of like the idea of inheritance as you probably used the word before seeing it in this class. The idea is this thing that it's inheriting from, the thing that is inheriting from it gets everything it has, right? Almost as if it had died and left everything to colored point. A little bit. So colored point then has everything that point has. If we, does the thing that colored point is extending point with is color. So we can define a new class. Let's do this. This will be an instructive example. Oh, I didn't inherit object here. What a silly thing for a professor to do. Object. I object. Class. Colored point. Inherits point. Def. Init. Ha. We shall take self. We shall take x. We shall take y. We shall call them x0, y0, and color 0. And that we shall, you can do this one of two ways. You can either copy this over, which, you know, not the most elegant solution. especially if this is more than 2 parameters. Programmers always want to minimize the amount of repeated code. Color 0. The other thing that you can do is you can do point.init self x 0 and y 0. There you go. What happens if you don't inherit object? Well, as you just saw, it still works. That whole time I was showing you guys all of this point stuff, point was not inheriting from object, and all of this was still working. So, I don't know, maybe it's just nothing? I don't know. Python inheriting object. Let's see. See what the internet has to say. I don't know. This is going to be a difficult thing to Google, so I'm just going to give up. So anyway, when you create a colored point, pardon me, the initialization method which we defined for colored point overrides that of just regular point. So unless we include an explicit call to the initializer function from point, or include all of the stuff that's in it, you're not actually going to get the same stuff. So you have to grab that stuff. So this is fine. If we want to make colored point blue and colored point green, we have a name error. Did I not? There we go. So that works. And notice we're still getting the quality that we were previously going. So there we go. So we have apparently, regardless of whether you put object, it's still the same. Yeah, it would make a lot of sense if they just kind of defaulted to inheriting from object. So I guess you don't need to put it explicitly. There you go. So notice right here that we're still accessing this equality method. So equality is still defined for these things. And if I comment it out, then it goes back to evaluating the memory addresses. But the whole blue or green thing, that issue isn't really entered into. Oh, okay. Basil says you probably needed it in Python too. Thank you, Basil. Yes, so you guys can all be thankful that you live in the modern era and you don't have to work in Python 2. You can work in Python 3, which is much better because you don't have to explicitly say that you inherit from object, because you do pretty much all the time anyway. So anyway, blue and green, we've got these. That's not really entering into the test of equality. If you wish for that to be the case, then you can do something similar. Define equality. You want to overload the definition. So return self.color equals other.color and point.eq self and other. I think that'll work. Yeah, yes, and then if we change this to blue, it comes out true. So there you go. Yes. So anything that is defined by color point is, of course, not accessible to point. But, you know, that's because inheritance is a one-way relationship. So if we define a new method called darken, which just takes self.color and adds dark to it, the string, q.darken print q.color dark blue for I in range 5. There you go. Dark, 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 dark blue. So, of course, if you tried to apply that to a regular point, it wouldn't work. Point object has no attribute, darken. So, it's a one-way relationship. Points do not have these methods, but colored points have everything in here and everything in there. That's the nature of inheritance. Cha. So, method overriding, of course, is what we have been talking about. Inherited methods may need to be redefined / overridden. The new method can refer to the inherited method using the same class name, using the class name and dot notation. So you'll notice point.init and point.string self, all of these types of things. Perfectly valid syntax. So, let's talk somewhat about the issue of classification. And this is super tiny, I apologize. Maybe I can zoom in on it. There, that's a bit better. So, the idea here with classification, the idea of inheritance is that it is a scheme of Constantinos says, I'm still having difficulty with the equals thing. So, equality operator, right? The equality operator takes two arguments, right? One before and one after. It's what we refer to as infix notation. So, typically, with a function, you have what's called prefix notation, pardon me. So you'd have some function name, and then you would have the arguments come afterwards. With the equality operator, you can think of it as a function in the same way, but infix. So the operator name comes between the two arguments, right? So in the case of equality, the function name is $_EQ_, then self and other, and then that's how that gets translated. So hopefully that's some degree of explanation for it. It just, like string or like init, it matches up to stuff that's provided by default in Python. So, The idea of inheritance derives from the idea of classification. We want to create a system of classification in order to characterize things in the world, right? So we've got, like, the classical example is in biology, right? So in biology, you have a system of classification which classifies all living things, right? You've got living thing, then you've got the kingdom Animalia, and you've got the kingdom Fungi, and you've got the kingdom Eukaryote and Prokaryote, etc., and the kingdom Plantae, of course. So you can think of all of these kingdoms. They all inherit from living thing. So everything that a living thing is defined as being has to be common to everything that inherits it. So the thing that makes a plant living is the same thing that makes a fungus living, or makes a, a paramecium a living thing. And you can drill down further. Let's say you wanted to talk about arthropods. Arthropods being a class of animal. Arthropods, everything that makes an animal is common to the arthropods and the mammals and the bivalves and the crustaceans. Well, crustaceans are a type of arthropod, but you got the idea. Everything arthropod would inherit from animal, which inherits from living organism, which would inherit from thing or object, material object, right? You could then push this system of classification down, arthropods, crustaceans, shrimps, a specific species of shrimp, that particular instance of a species of shrimp that is on my table about to be eaten by me. All of these types of things. Like, this is the inspiration from which inheritance was taken. So if you think about things with... Yeah, I know that, like... I hope for all the biologists out in the crowd there, I'm doing a reasonable... I'm doing your discipline justice. Biology is really cool, by the way. I just wanted to put it out there. Chemistry is really cool. And biology is also really cool. Biology is applied chemistry. Chemistry is applied. Chemistry is applied. Oh, yeah, no. How's it go? Physics is applied math. Chemistry is applied physics. Biology is applied chemistry. Psychology is applied biology. Sociology is applied psychology, and that's the hierarchy of the sciences. Anyway, and math is applied philosophy. Yes, fewer things explode in biology, I guess, which makes it kind of... Or are you talking about, like, super cooled, like, what is it? Yeah, I suppose any discipline in which you use liquid nitrogen, it has to be cooler, right? Anyway, so the idea of inheritance was first used in a programming language called Simula 67, which should tell you how old it is, because they mean 1967, for simulation programs where objects of the real world were represented by objects in the program. These were some of the first attempts we made at generation of artificial reality. They didn't go... it turned out that other areas of computation were more useful. Later on, in Smalltalk 80, inheritance was used for general programming. So anyway, in our particular example, point inherits from object, whether or not it says so explicitly or not, and colored point inherits from point. So you can use type to tell you what the object that you're dealing with is, right? So if we go to here, boop a doop a doop, type of Q, attribute error. Oh, I should comment that out. So type of Q is main.coloredPoint, main being where colored point is defined. However, this doesn't tell you what else Q is, right? It tells you it's a colored point. From this somewhat facile example, it's reasonably obvious that colored point is a, variant of point because, they're named similar things. However, it's not always obvious what something inherits from. If we go back to our animal example, it might not be obvious to someone whether a clam is a mollusk or a crustacean. I mean, it should probably be obvious, but so if you want to be able to tell whether something is an instance of something, there's actually a test for it. So is instance, I believe it's not, is instance. And then you provide that, and you provide the class that you think it is. And then it provides you with a Boolean whether or not is the object that you've provided is an instance of the class that you've provided. So if we say colored point, colored point, there we go, that's true. How about my error? That's false. And object, that's true. So this is useful. You can tell if an object is of a particular class. Is instance is useful. There you go. So, okay, now we start getting into the real shizzle dizzle. So now we need to talk about what's called multiple inheritance. So while it is true that, you know what? We're going to just have to redefine everything here. While it is true that you can have things go linearly, you can also have things inherit from more than one thing. So in this particular case, and I'm just going to comment this, I think, just because this is like the old version. Octothorpe. There you go. So we have this new class. This class provides us a bunch of the... is there a way to print all inheritances? Ooh. I don't know. Probably. But I don't know. I'm sorry. There might be something in the Python documentation. So anyway, with respect to color, we now have a color class. It has an initializer. It has this darken method that we were using before. It's got it's got a test of equality, and it's got a string thing. So what do we do if we want to combine these two classes into one class? We create a multiply inheriting class. So class colored point. I'm just going to fix the spelling here because this is Canada, gosh darn it, and we are going to have our British spelling if it kills us. There we go. So, colored point will inherit from both point and color. Oh, yes! Can be a comma delimited list of classes that you can inherit from. Yes, sirree, Bob. So, with respect to that, you can then define your own initialization, which is going to follow basically the same convention as this, so I'm just going to copy that over. Da-da-da-da. Then we get points dot init. And we give it self x and x0 and y0. And we have color dot init. And give it self and color 0. There we go. Did I miss one? Aha! Thank you. When you've programmed for a long time, sometimes you get like string o vision, where like you look at code and like your brain doesn't see stuff like that's not in the syntax highlight color that you're looking for, even if ostensibly you should be looking for it. And that happened to me. Thank you. American Spy spotted. Ooh. What? It's okay. I don't think we have to worry about the Americans. If America had wanted to conquer Canada, they would have done so a long time ago. But anyway. Yes, here we are. Oh, there we go. So there you go. You can refer to the multiple things inside, and you can just kind of split things up and direct things as you like. It's very cool and convenient. They did try, yes, that's true. They did try that one time, and we were like, BTFO Americans. Ha 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 ha. Although that was kind of, that was kind of a silly war. There was really no reason for it. Aside from American Manifest Destiny, at least that's what the Canadians tell themselves. I guess maybe we were provoking them or something. We were just being so essentially still a British colony, they just couldn't stand it. Anyway. So, you might say to yourself, okay, sure, you can do this. Why? Why would you want to do this? The answer is, sometimes, this basically frees color up so that it can be inherited by other things. Maybe color is a property that we want to be able to have a whole bunch of different types of things inherit. Then, if it's not wrapped up in the definition of point, we can do that. Yes. Yeah. Let's just not talk current politics. I don't want the stream to become essentially political. That can happen really quickly. It's not like I'm not angry or anything, but let's try to keep the politics out of class. So yes, multiple inheritance. So color only serves as a base class for inheritance. You would not necessarily create objects of that class as it's incomplete for practical purposes. Classes that only serve for the purpose of inheritance, but not for actual object creation, are called abstract. Their purpose is code reuse. There is no particular syntax which designates a class as being an abstract class. This is a designation that we human beings place upon certain classes. It is just a little piece of nomenclature. There's no difference when programming. So, let's do an example. Let's see how much we can get through. Birthday calendar. The task is to design a birthday calendar with the following operations. This is a letter opener, by the way. We want to have the ability to clear it. We want to be able to add something to it. We want to check to see if a name is within it. And we need to have a set of names with a birthday on a particular date. This requires a data structure with entries for names and dates. The data structure is shared among the operations. A class allows us to encapsulate operations on a shared data structure. So let's take a look at our Python interpreter. So class bday inherits from object. There we go. So define an initialization. It will take self and nothing else, I think. We will have self.cal. That will be our calendar. It shall be initialized to an empty dictionary. Dictionaries, my friends, dictionaries. So what did we want again? Clear removes all names from the calendar. So def clear. You got two options here. You can either re-invoke the initialization function, or you could just do self.cal is equal to an empty dictionary. bday. Oh, by the way, classes are capitalized by convention. bday dot, at least custom ones are. Init self works too. There you go. So there we go. Add name date. Def add name date. So self.cal at name is equal to date. Def, let's see what else we got. Contains, checks if a name is in the calendar. So contains name. Return name in self.cal. Remember that checks the keys. So you may notice here a thing that's going on. Normally, we're pretty strict about functions always having to return something. That isn't actually a strict requirement in Python. You can just have functions that run through a bunch of stuff and then don't produce anything as a return. However, when we talk about methods, you may notice some of these have return values and some of them do not. The ones that have return values, these are get methods, and the ones that have no return value, these are generally set methods. This is sort of nomenclature that you'll hear probably at some point with reference to classes. You'll have getters and setters. Getters are the things that extract information from a class, and setters are things that put information in the class. So these guys do not need a return statement. The fact that they are modifying the internal state of the class is enough for our purposes. However, if you want them to return something, they totally can. It's up to you. And we got one more of these. Def, what is it here? Birthdays, the set of names with a birthday on a date. So, oh, this one's a little more complicated. Birthdays on date for person in self.cal. Out is equal to an empty list. Sure. If self.cal at person is equal to date, out is equal to out plus concatenated with person. There we go. Return out. Also, it's not required, but it's useful to leave a space here just for the purposes of being able to read this stuff. Just so you know. So there we go. And let's see how we did. And then we'll go for a break. Birthday calendar. Def init, yes. Clear, yes. Add. Yep, that's how we got it. Contains. Yep. Birthdays. So they're returning a set rather than a list, but it's essentially the same operation. There's also the string thing here. They're overloading string for this, which is not something they asked for in the question, so there you go. But yeah, so we did all right. And that's how you write a class. So, good. Excellent. We will return after the break. And we're back. Welcome back. Indeed. So, yes. So that's the birthday calendar. Second example, mean calculator. It's not like 1 plus 2, dummy. Oop, that's a symbol that shouldn't be there. Anyway, the task is to design a calculator for the arithmetic mean with the following two operations. We've got add, n adds n to the collection, and mean returns the mean of the collection. The mean should account for the same number being added multiple times. So, yes, let's try to implement this. Ba-dunk, doodlepad. Def, mean calc. Inherits object. Well, I guess it doesn't have to, does it? And it's a class. Class. There we go. Def init shall take only self. Self dot collection equals. Or no, well, that's too long. List. We'll make it a list. Def add self n self dot collection dot append n def mean self return self dot collection dot sum, I think. Well, you can do it the old-fashioned way anyway. For thing in self dot call collection sum plus equals thing return sum divided by length of the collection. There you go. And that should work. So for example, if we declare m is equal to mean calc m dot add to there we go, m dot add 4, m dot add 5, m dot mean. There you go. I think you'll find that accurate. Maybe. Yeah, I think so. So, there you go. Very highly similar to the thing that we just did. The only real difference being they did the manual, the sort of using plus append instead of the append method, but, you know, differences be trivial. So, here's a more efficient mean calculator. So rather than keep a list of everything that has been entered into the calculator for the entire period, you can actually add, you can keep two variables. One keeps track of the sum of all of the things as you add them, and the other keeps track of the number of things in the collection. While you are not actually maintaining the collection itself, you have all of the things that you need in order to calculate the mean. So, in that sense, you are, while you are not, there are certain trade-offs, right? A lean mean calculating machine, indeed. So, the trade-offs here, number one, this calculator takes less memory overall than this one does. Just flat out. Oh, and sum does work. There you go. However, the thing that it doesn't give you is it does not provide you with the ability to have access to the things that were actually entered into the mean calculator. While this particular iteration of the mean calculator doesn't need that stuff, it isn't inconceivable that at some point in the future, that data might be necessary. For example, it would be difficult to run some other more complicated statistics on the data set, such as standard deviation, without actually having all of the values in the collection present. If you just need mean, then this is a sufficient solution. But if you want to expand this this mean calculator into a full statistics package, or even like expand it with a couple of additional statistics functions, that might be problematic. So yeah. Also, this mean calculator calculates the mean more efficiently. You see that here we've got self.s and self.c. It's just a division operation on two existing numbers. Whereas with mean calculator 1, we are having to invoke sum and we're having to invoke length. In terms of my calculator, that's the presence of that loop, right? In this one, you get away with not even needing to use a loop at all, which is cool. So here's a question. If only add and mean are used, can you distinguish mean calculator 1 from mean calculator 2? i.e., do they look the same in terms of their behavior and functionality from a programmer's perspective, from the perspective of someone who uses these things? I will give you guys a moment in chat to enter your answers now. Why would you define a mean calculator class instead of just defining a mean function? Because this is a somewhat trivial example used to demonstrate a particular aspect of the thing of classes. Yes, absolutely, there is a mean. You could definitely have a mean function that just operates over a list. It's, and we have in the past in this course, that has been a past example in previous slides. The advantage here is that you can accumulate these values into a separate object. It keeps track of the collating of the objects for you. Like if you're generating data over time, right, you can either write all of this stuff to store everything in whatever means you want to store it in explicitly, or you could, instantiate a class which encapsulates that issue or that functionality. Hopefully that's some kind of a answer. Classes aren't really useful at this scale. They become useful very quickly, though. Even if, you can imagine if you had, 3 or 4 lists or dictionaries or complex data structures that all interact, that a class would be the way to go about that. So what is it, guys? A or B? Yes or no? Is the chat working? Have I been de-chatted? The answer is B, no. From the perspective of a programmer, you can't tell the difference between these two. You can't tell the difference because they take the same inputs and they give the same outputs. Yes, thank you, Konstantinos. Regardless of the internal operation of the class, the external operation of the class Well, actually, everybody is saying A. So, well, there is the issue of the different declarations, right? Like one is mean calculator 1 and the other is mean calculator 2. But, and I often have people say things like, oh, well, you could distinguish between these two based on the amount of memory that they use. And that's true. You could tell which one is being used by the amount of memory it's using. However, from the perspective of just simply, do they do the same thing? The answer is yes, they do the same thing, and no, they can't be distinguished. But, people who profile code can always tell the difference between one thing and another. So, let's talk about abstraction. Functions provide functional or algorithmic abstraction. Functions can be used without needing to know the algorithm they implement. The documentation specifies declaratively what a function computes. It is a tiny sword, yes. This is a letter opener. I've had it for a very long time. The end is kind of pointy, but it's otherwise very dull. Okay. I miss having like a piece of chalk. So this is what I'm gonna do. Sorry, guys. It's just you gotta do the little things that make you feel like your job is normal right now, you know? Anyway, so yes, classes provide data abstraction. Classes can be used without needing to know the data structures of the implementation. The documentation refers to abstract data structures that may or may not be present in the implementation. So, in the same way that a function hides instructions, classes hide data so that you don't need to know what's going on in there. This is very useful. So, however, given that the purpose of this is to hide information from people, one of the useful things you can do is hide information from people. There's actually a way that you can hide, you can make data that's inside of a class inaccessible to people outside that class. Or to put it in terms of scope, you can make it so that a field of a class is only accessible inside of its local scope. So, the way that you do this is by prefixing anything in a class. I believe it works on methods as well, but particularly with fields, if you put a double underscore in front of it, that member will be private. So in a lot of other programming languages, you hear about public versus private variables. Public fields, public members, public variables are accessible externally to the class. Private ones are not. You're sort of locked out of it. So let's modify this. And basically, this allows you to enforce your data policy, right? So if we let's do mean calculator. So if we prepend, and you got to do it with every one of them, unfortunately, that's one of the annoying things about Python, is that you can't just declare it once and be done with it. If you prepend all of these things with the double underscore, the collection is now private. That means that it cannot be accessed outside of the mean calculator. So, for example, oh goodness, I should have done an example first. But if we wanted to do m.call and just print it, it works. Okay. It shouldn't. Ah. Okay. What? I think I have to reload the notebook. Right, clear its memory. Rip. So, run that. Run that. Mean calc has no attribute that. How about this one? Yes. So basically, it won't even tell you you don't have permission to access that. It'll just say, I don't know, that thing doesn't look like it exists to me. So, yes. Call is now inaccessible outside of the context of the class itself. However, all of the methods that use it are still fine. You can still get data out of the class, out of the object. You just need to get it out using the approved mechanism, which is the method. So that's a data enforcement policy. It's a useful thing to know. A lot of other languages use that kind of thing. So, yep, good. The final mean calculator. This has, you can see that all of the individual members here have been made private using double underscores. So there you go. So, here is an example of a scene from a popular video game. In fact, it is Super Mario Brothers, one or the other of them. I think the one with Yoshi's was the one on the Wii U. So, here's a question. From the things that you see on screen, what are some classes that we could have here? Please feel free to answer in the chat. What classes would we have here? So, we've got enemies, we've got Koopa, sure. Heroes, reward, player, yep. So, yep, coins, yep. Projectiles, power up, terrain, yep. So, if I were to design a Mario game, I would have several types. You would have interactables, which would be things that you could interact with in the terrain. Things such as the brick blocks, question blocks, blank blocks, pipes, even the ground, that could be in that class. Enemies, like all enemies would have certain features. You know, obvious, if you think about something like a Goomba versus a Paragoomba, right? The Goomba here and versus the Goomba with wings. Obviously, a Paragoomba is just a, modification of a yeah, I said Mario because that was on the Paragoomba is just a modification on the Goomba frame, so it would be inheriting from Goomba. And the interesting thing about programming video games is that things like models for video games models for video game characters can be properties of classes, right? This is how the popular video game engine Unity works, and that's a thing that probably... Yeah, I'm just gonna give it a second so it comes back here. Boy, look at that dip. Man. So, hi. Welcome back. Sorry about that, folks. Had to go bump my router. Yes. So yeah, we're, as one of you observed, we're pretty much almost all the way through these slides. So I would like to show you guys something fun when we are finished. So suppose you want to create a set of data structures for... we already did that. So here's an example. Levels, characters, widgets. Characters can be playable or non-playable. Non-playable could be Goomba or Koopa Troopa. I know that Yoshi is like hypothetically a character, but like when Mario is on Yoshi, he's functionally a power-up. He's not, like, in terms of code, he's not dissimilar from like the Tanuki tail. So it's more like when Mario gets hit, a running Yoshi is spawned at that precise moment, and then if you catch him, then you go back to having the Yoshi power-up state. But yeah, anyway. Yeah. You've never played Mario and you're... Oh, I'm sorry. So Super Mario Brothers is a very popular series of video games which feature what is essentially a stereotype of an Italian person who basically runs and jumps on things. Everything that's not him or these guys are enemies, essentially. This is a power-up. It's, basic platformer type stuff. Go play Mario. Your homework is to go play Mario. There are definitely Mario games in which Yoshi is like a character in the proper sense, right? Like if you look at a Mario Party or a Mario Tennis game or anything where Yoshi is selectable from a roster of characters to select, then Yoshi would be like a a playable character object in that sense. But in a regular Mario game, he kind of isn't, which is kind of funny. Anyway, so some possible properties that might be, yes, some possible properties that you might have for the character. The name of the character, whether they are big, whether they have a feather, number of coins acquired, although I think in this particular one you share a coin count between all characters. An X and Y position, very important. A method to move from one X and Y position to another. That also might be useful, although not the way I would do it. Collect coin, C, sure, draw on screen. That's an important one. And for a question block, X and Y position, of course, contents, whether it's used or not, a smash method, and a draw on screen method. So that's cool. And that is, of course, the end of the presentation. So let me show you guys what all this stuff looks like in the wild. So I have not to be a shill or anything, but I kind of do a little bit of game development on the side as a hobby slash business, business hobby, whatever. I may have talked about it before. I have a pinball game that I made and released on Steam. You can look it up if you want. It's called Super Steampunk Pinball 2D. That was released a couple of years ago, and basically, actually, since sort of Christmas break of this year, I've been working on another project, which is the next game I'm going to release. It's called Hexi-Hashi. It is based on, if anybody has heard of or seen the Hashi puzzle, sometimes called Bridges. It's yes, yes. The pinball game's okay. There's sort of this thing that they say about like creative things that you do that you like absolutely hate everything you did 5 years ago, and for me it's more like 2 years ago, which is about as long as that game's been out. It didn't do too badly, but you know, I mean, it didn't make much. So anyway, there's this puzzle, this company that produces puzzle books, that invented a large number of these different types of puzzles. One of which is called Hashi. Yes, and basically, my concept for this particular game was to take the Hashi puzzle and adapt it for a hexagonal grid as opposed to the rectangular grid that it normally operates on, which, once you finish something, you're better at creating than you were when you started. That is truth. Thank you, Mars Lettuce, for truth. So, I just want to show you guys how everything inside of the development environment that I use, which is Unity, is in fact objects. It's so much objects. So basically, inside of this game environment, I have the object hierarchy, which is, you can think of it as these are the instantiated objects, right? This is your uninstantiated objects, or classes. So you can think of everything down here as a class, and everything here as an object. Although there's kind of a bit of an overlap here, because this is actually showing you a number of actual files and stuff like that, but it functions in that manner as well. So anyway, if you take, for example, a particular button here, you can see that it has a whole bunch of different attributes, which are, what do they call them in Unity? Components. They call them game components. So in Unity, you can think of these game components which have been added to a game object. And, I'm not sure how they do it in like the underlying code, but you can think of this MoveMaster object as inheriting a button, right? And it has script. It has button script as a component, which, is similar to the idea of inheritance. And, it has various things, and objects contain objects, which contain objects, and it's objects all the way down. Like, oh my goodness, so many objects, actually, though. So, yeah. And so it would be, I would be in remiss if I didn't then show you guys what the game looks like, which is the thing that I accidentally clicked on a few lectures ago. And, yeah. So, bam. So this is Hexi-Hashi. you can see I've got this cool little background going on. It's kind of interesting. Each one of these triangles is actually a object as well. However, each one of these objects has a certain disproportional. Oh, ignore that up there. I was using that for debugging purposes. Each one of these triangles is like hooked up to a global script, which tells it how much of rotation everything should be at, and then it adds its offset, which is how you get this sort of passing through effect, which is kind of cool, as well as the color gradient. But anyway, so in order to play the game, essentially you have all of these nodes, and you have to make bridges between the nodes. Bridges can be single or double, and the idea is each node should have the number of bridges equal to the number of ticks on that node. They were originally numbers, but it turned out that having them as these little triangles that turn colors, that actually is like more readable, like more quickly readable. So I decided to keep that because, you know, when you're making a game, one of the things that you should always endeavor to do is make the game as easy to play as possible. And, you know, that's sort of how game design goes to an extent. But yeah, and I've almost got the solution to this one. But anyway, you guys can sort of see how, like, the whole thing is actually made with extremely simple components. I have not yet. I think I had to make like 1 or 2 sprites, but everything else in this whole game is made from the pre-baked Unity assets, like the pre-baked Unity hexagon and the pre-baked triangle and rectangles of various sorts. Like, everything is yeah. Oh, question. What are the controls on Super Steampunk Pinball 2D? Shift keys are the flippers. Down is the plunger. If you have sticky keys on your computer, you'll want to turn it off because you'll be hammering the shift keys. But also, it might still. I hope it gives you like normal difficulty by default. But anyway. But yeah, so that's some fun stuff that you can do. This is the kind of thing that you can do with programming. You see how these hexagons are reactive to the point of the mouse? I can actually show you that script if you're interested. So hexagon scripts. Background hex script. Maybe not. Let's take a look. Oh, and for any of you who might be interested, if you're looking for an IDE, Visual Studio, for Windows at least, Visual Studio Code is a pretty good one. I've had no complaints so far. So you can see that I'm actually using classes, like explicitly using classes within the context of the scripts that I'm writing for this game. Get out of here, release notes. Nobody cares. Nobody reads you. So you can see I have sinusoid, which actually is a sinusoid function that, you know, basically it just wraps this equation, which is, you know, fine. I was experimenting with classes when I was doing this, but how many bonus marks if I leave the game a 5-star review? If I admit to something like that, I would that could be considered an instance of corruption. In high school, instead of an exam, we had an end-of-year assignment where we could make a game of any type in Python. That sounds like a cool high school. PyCharm is a nice one too. The Git integration is nice. Yes, PyCharm. I've never used it, but I've heard good things. Yes, I know that I think Eric the TA used that last year, and you can get some really cool stuff going with it. There are a lot of add-ons for VS Code, which are quite cool as well. But anyway, so yeah, basically it just refers to a background controller hex script, which it's the script that everything refers to. It's responsible for drawing the hexes at the beginning, like when the level loads, it draws them all in using instantiate at their correct positions, and then it just keeps an update on its color and scale values, which again, a slight offset is applied to each hex. If you take a look, hello. H offset is a function on it. It's relative to the row number, or row number and column number, or just column number. So there you go. Do you like Visual Studio Code or Jupyter? For teaching a course, I like Jupyter. For doing any real coding, I would use Visual Studio Code, or whatever programming IDE you would want to do. The thing, I really like Jupyter for teaching, because it makes everything, like, you can organize an assignment really nicely in it. However, if you're doing any like serious programming or any like individual projects or anything like that, I definitely think that you should use anything except Jupyter, to be honest with you. However, all of the Python that you learn in Jupyter will be applicable, which is nice. So, yeah, PyCharm, apparently. VS Code has some good add-ons as well. But yeah, generally speaking, though, when people are making programs, people don't really write very many command line programs anymore, unless you're doing something obscure for a thesis or something. Most things you want, like some sort of a graphical user interface or something like that. Unity is built kind of on top of the .NET framework and the C# sort of thing. C# as a language. C#, if you know Python, you should know C# pretty well. Like you should be able to pick it up anyway. Note the curly braces. Note the semicolons. But aside from that, pretty much everything's pretty much as you would expect it to be. One big difference in terms of field declarations. First of all, notice that when you declare something, you have to declare what type it is. Oh God, oh shocker. But you also declare, well, you can declare your thing, like fields that are at the level of the class get declared outside of any function. But that means we are not doing real coding. That is correct, sir. You are taking a course in coding. So I sometimes get people asking me questions like, I really enjoyed this course. I really want to learn more about programming. What are some books that I should read? Or what are some more courses I should take? And like, honestly, for a lot of people, the next step up, the next thing to do when you want to improve your programming skill is you need to take on a project. Find something that you're interested in doing and do it! Just code, man! Or woman, or everybody else too. You'll learn way, way, way more from trying to do something practically than you would ever learn from 1,000 of my test questions, right? Like, and, that's kind of, to some degree, the whole problem of teaching people programming inside of a class like university class context, not like object-oriented class, uh, it's kind of like it's never going to be as interesting on your resume as if you have a couple of good portfolio projects. So, like, if you the listener want to continue to do code, like maybe even professionally, maybe just for, it's a good thing to know. But if you want to go on and do code for a job, everybody and their monkey has taken a intro Python course, right? But if you have a couple of good portfolio projects, that can make or break your application, right? Not to mention, you'll just learn so much. But the trick is that you have to choose like a non-trivial example, right? Like you could, if you really wanted to, you could like to learn SQL, you could like set up a SQL database of every single movie that's come out in the last 50 years or something like that. It like just because you've done that doesn't mean that, like, certainly you would have done a great deal of data entry, so you would be good at data entry, but you have to compare that to finding a need and filling that need with programming. But anyway, so that's generally speaking, this is like a little side project I'm working on. This environment is incredibly object oriented, so honestly, oh, what? Okay. Windows ran into a problem and needs to restart. You should close this message now and save your work. What the heck, man? Okay, well, I guess that's we're going to be closing down the stream a little bit early then. Thank you very much. If you have any more questions, please email them to me or send them on Piazza. Have a nice evening, folks. This is your professor signing off. Ta-ra.